right, third graders, we are using our Geoboard today to help us learn about the attributes and the characteristics of different quadrilaterals. So let's begin by your Geoboards. Mine is online, obviously, and yours is physically on your desk with rubber bands. Really quick, make sure that you are using the rubber bands for mathematical tools, not messing around with them. Your teacher will take them if you're not using them properly. So I have lots of different colored rubber bands here on my online one. You probably only have a couple choices. You're just going to need one rubber band today. All right? Well, maybe two to get started. So we're going to start off just by talking about a couple of the things that we're going to need to talk about today. One of the attributes that we're going to be talking about are parallel lines. So using two rubber bands, I'm going to make parallel lines on my Geoboard. So go ahead, while I'm getting mine ready, go ahead and take two rubber bands out and try to create parallel lines on your Geoboard. Think about what parallel means. And a lot of this time I'm going to say press pause, and then you can do it. You're not just watching a blank screen waiting for me to tell you more. So go ahead and make two parallel lines. Press pause while you're doing it. All right, parallel lines, if you remember, go on and on forever in the same direction, and they're always going to stay the same distance apart. So on your Geoboard here, I can make a parallel line with these two, even though they're not the same length. One of the things that we often think about wrong is that they have to be the same length. No, these two lines are parallel. They're going to go on forever in both directions, and they're never ever going to touch. I can also make my parallel lines go up and down. They are going to go up and down, and they are not going to touch. This is making them parallel going this way. So they can go either way as long as they never ever touch. These are also parallel lines. So parallel lines go on forever in both directions, and they never touch. You can also have them, they don't have to go straight up and straight down. They can go diagonal. They can go across here. Pull that up there. I can make parallel lines going this way also. They just have to never touch. Those are parallel. So a lot of times in our shapes, they're not always straight up and down also. All right. And then obviously the opposite of parallel or intersecting. All right. And it's a little bit confusing. So real quick, these lines right here, it confused some of my students last week. Are these parallel or not? My students say, oh, I know they're not touching, Mr. Klaus, so they're parallel. No, they're not touching yet. But remember, lines go on forever. So if this line keeps going, it is going to intersect with that. All right, so keep that in mind when we are doing our shapes today. So our first quadrilateral, all right, so just make, and to be a quadrilateral, you have to have four sides. All right, so we can make any kind of quadrilateral. So on your Geoboard, make any quadrilateral. Go. All right, so there are just so many different quadrilaterals that you could have made. All right, to be a quadrilateral, the only requirement is that it has four sides. 1, 2, 3, 4. And if it has four sides, it has four angles. All right, so any four-sided shape. This is a quadrilateral. This is a quadrilateral. This is a quadrilateral. Even this is a quadrilateral. 1, 2, 3, 4. All quadrilaterals. To be a quadrilateral, you have to have four sides and four angles. All right? And we're going to get into a little bit more detail of the quadrilaterals as we get going. All right? So the first one we're going to start off with is a trapezoid. A trapezoid. So go ahead and make a trapezoid on your Geoboard. Go. Press pause too. So keep in mind, your trapezoid does not need to look exactly like mine. You just have to learn the attributes of a trapezoid. This trapezoid I made right here, maybe it looks like yours, maybe it doesn't. But to be a trapezoid, the only requirement is it has four sides, and it can only have one pair of parallel sides. In this case, the top is parallel to the bottom. The left is not parallel to the right. Like we said earlier, if they keep going on and on forever, eventually they're going to intersect in there. All right? Lots of different types of parallels. Lots of different types of trapezoids. Okay? I can make one here, and you can make one here with me. We're going to make one so that the left and the right sides are parallel this time. So we've taken it, we've just kind of turned it sideways here. So here, if I look at my left and my right, they are parallel. They're going to go on forever and not touch. Remember, they don't have to be the same length as long as they don't ever touch. These over here. So you can make lots of different types of trapezoids. So go ahead and press pause and make a couple different types of trapezoids. All right, the next one we are going to make, you've been making since kindergarten, and you're pretty familiar with it. Make a rectangle. All right, make a rectangle. Pause it, and make a rectangle. All right, you should have all made your rectangle by now. And once again, a bunch of different ways you can make your rectangle. You can make it look like this. We could have made it go up and down like this. Could have made it a little bit skinnier. I'm going to bring mine up here. All right, so now, obviously in kindergarten you know what a rectangle is, but in third grade we have to learn the attributes. So we have to be a lot smarter than that. We have to know what it actually means to be a rectangle. All right, so a rectangle, we're thinking about three things: the length of the sides, all right, the angles, and are they parallel? So we call it our LAP, L-A-P, length, angles, and are they parallel? So with a rectangle, the opposite sides, the length of them are the same. The top's the same length as the bottom. They are also, opposite sides are also parallel on both of these. All right? They're both the same length. Opposite sides are the same length, and opposite sides are parallel. All right? And the angles, so the LAP, length are the same. All right? Opposite sides are the same length. All right? P, opposite sides are parallel. And the A, the angles, they're all right angles. So if you think back to way back when we were talking about angles, we had obtuse, acute, and right. These are squared off angles, so they are all right angles. All right. So from a rectangle, once again, let's make a very simple one that you've been doing your entire life. Make a square. All right, shouldn't take you long. You can make a big square. You can have made a smaller square. I mean, we can make it as small as this if we wanted to. If we wanted to get really tiny. Or if we wanted to make it really big, we could extend it to the whole corners of the Geoboard. Now, your rubber bands might not stretch that far, so please don't try to stretch them out if they're getting thin. Just go to a smaller square. So let's go through our LAP here, our LAP, length. What makes a square special is the length. All four sides are the same. All four. They are all equal size. Angles. So LA, the A for angles, it's just like a rectangle. They're all right angles. So those in a rectangle share that. And P, parallel. Are the sides parallel? Top is parallel to bottom. Left is parallel to right. LAP, length. All four sides are the same. Angles, they're all right angles. And P, opposite sides are parallel. Fantastic job. So we've done quadrilaterals, trapezoids, rectangles, and now squares. So what we're going to make next is a rhombus. So if you think you can make a rhombus, go ahead and make a rhombus on your Geoboard. I'm going to give you some time to do that. All right, so for a rhombus, all right, all I'm going to do is start off with my square. I'm going to stretch one side out to there. I'm going to bring this one in here. So it's just like a square that has been squashed down. It's like someone sat on it and just squashed it down sideways. All right. So let's go through our LAP, L-A-P, the length of a side. We started with a square, and if you remember, a square has all four sides are the same. So the length of a rhombus, all four sides are the same, just like a square. The angles, here's where it gets different. If you look here, these angles no longer, since we squashed it down, they're no longer right angles. All right? So they're not right angles. Length, all four sides are the same. Angles are no longer right angles. And P, parallel. Opposite sides are still parallel. Even though they're slanted, they are still parallel. All right? So we've learned about quadrilaterals, trapezoids, rectangles, squares, and now a rhombus. All right, so now you understand them a little bit more like third graders. You not only need to know the shape, you also need to know the attributes of them. So hopefully this helped, and hopefully you enjoyed your geoboards.